This tutorial will show how to create non-prismatic members. To create a non-prismatic member, we specify a starting and ending section, the length of the segment, and how the properties are to vary over the segment. For our example, we will use a simple gabled frame, as it is common to use sections with varying depth in these frames. Here, note that all the sections are initially of constant depth, W12 by 26s. If we go to the extruded view option, we can see that the depths do not vary. To create a non-prismatic member, we start by going to the Define Section Properties Frame Sections command, where we have previously defined two sections, a W12 by 26 as shown on the model, and a W21 by 44 section. These are the two sections we will use to define a tapered member. Clicking on the Add New Property button, we scroll down and select Other, and then click on the Non-Prismatic button. We will name our section Tapered. As previously mentioned, we need to specify starting and ending sections for our tapered member, and in our case, the starting section will be the W12 by 26, and the ending section will be the W21 by 44. We will specify a segment length of 1 with a length type of variable. This means that these two sections are located at the very ends of the member. In this case, length is a ratio because we have specified a length type of variable. Had we selected absolute, length would have been the actual length of the member. As an example, suppose we are defining a member that is 9 meters long with two segments. We want the first segment to be 3 meters long and the second segment to be 6 meters long. Using the variable option, we could assign a length of 0.5 to the first segment and 1.0 to the second segment to get the proper ratio. If we use the absolute option, we would specify 3 meters for the first segment and 6 meters for the second. Next, we will specify how the moment of inertia should vary. For wide flange type sections, the moment of inertia typically varies in the major direction as the square of the depth, so we will select parabolic. In the minor direction, only the width is varying, so we will select linear. Click on the Add button, and we are defining only a single segment, so we can leave this form. However, note that if only a single segment is defined, the variation is always assumed to be over the entire length of the member, regardless of what is specified for the length. Note that the tapered section has been added. Next, we will turn off the extruded view and show the local axes of the members. If we look at this particular member, this is the starting end, and this is the ending location, based on the orientation of the local 1 axis, which runs along the longitudinal axis of the member. Now we will assign the tapered section to all of the frame objects. If we change to an extruded view, we can see that the members are all now tapered, with the variation in depth following the orientation of the local 1 axis. Next, we will add a second segment to the non-prismatic section. We will modify our previously defined tapered section. And we'll change the length factor for the first segment to 0.5. We will define a second segment that starts with the W21 and ends with the W12, also with a length factor of 0.5. This has created a section that starts with the W12, goes up to the W21, and then tapers back to the W12. When we update the drawing, we can see this taper in the members. A 3D view shows the flanges of the members. In conclusion, non-prismatic members may have any number of segments, with each segment defined by a starting and ending section, and the properties may vary over the length of the segment in either a linear, parabolic, or cubic manner. This ends this tutorial on non-prismatic members.